Hi guys, this is lesson 3 in unit 3, graphing and writing linear inequalities. Solutions of linear inequalities. A linear inequality is an inequality in two variables. Usually you'll see an x and y. An ordered pair is a solution to a linear inequality if the point makes the inequality a true statement, and we will look at a few examples so you can see how the solution for the linear inequality should satisfy the inequality. Let's take a look at the first example. We have y is greater than x plus 1. That's a linear inequality in two variables because we have x and y, two variables. These are possible solutions. Let's find out if any of these points are definitely a solution for the linear inequality. So the first point is 1, 3. We know that 1 is the x-coordinate for the point and y is the y-coordinate. So I'm going to substitute y with 3 greater than x, which is for this point is 1 plus 1. So we have 3 greater than 2, which is a true statement. That means this point is a solution for the inequality. Let's take a look at negative 1, 5. So 5 is the y-coordinate, greater than negative 1 plus 1. Negative 1 plus 1 is a 0, so that means 5 is greater than 0, which is again, is a true statement. We have negative 5 is x in this example, so we're going to take negative 2 for y, and greater than negative 5 for x plus 1. We have negative 2 greater than negative 5 plus 1 is a negative 4. That means again that this point satisfies the inequality. In the last lessons, we learned how to graph a linear equation. Today, we're going to learn how to graph a linear inequality. So if we look at the linear inequality here, we have y greater or equal than negative 2x plus 5. The parameters that I need to graph this inequality is m equals negative 2. That's the slope. And the y-intercept is 5, which is b. So in this case, I'm going to start graphing by identifying the y-intercept, which is right here. I'm going to use the slope to be able to identify a few points to be able to make a nice line for this inequality. So I'm going to go down 2 points over 1 to the right because the slope is negative 2 over 1, which means 2 points down, 1 a point to the right, 2 down, 1 to the right, 2 down, 1 to the right. I'm going to go the opposite way. So I'm going to go up 2 points and 1 to the left, up 2 points and up 1 to the left. So now I have these points that represent the equation with y equal negative 2x plus 5. And since I have an equal sign underneath the inequality, that means I'm including this line. For that reason, I'm going to have to make a solid line. Let's assume that there was no inequality, there is no equal sign underneath the inequality. In this case, we're going to have to make a dashed line instead of a solid line to represent that the solutions on that line are not included for this inequality. So now I have y greater. So y greater that means that I need to shade to include all the points where the x and y coordinates satisfy this inequality. And when we see y is greater, that means I need to look at the y-axis and find out where the y value are greater in that case. So if I look at this point, the y-intercept, I can see that all the y values that are greater than the y-intercepts are right here. So that means all this area include the solutions for this inequality. Any point on the line or on the in the shaded area of this inequality satisfy this inequality. Any single point that is not in the shaded area or on the line does not satisfy this inequality, which means the only points that we can choose for in the solution set are in the shaded area or on the line. So I'm going to choose this point in the shaded area to include as my solution, which is 3, 6. I'm going to choose another point on the line, which is this one, 3, -1. And then I can choose a point right here, and this point is a -5. And again, these are not the only solutions. Every single point on the line and in the shaded area in this situation is going to be a solution for this inequality. If the inequality includes less than, that means I'm going to have to include every single point that is below the line to include all the y's that are less than the y-intercept. So these are the steps that you need to remember to be able to graph a linear inequality. Take a minute to put these steps down and use them when we do our examples in class.